Okay, well, very excited to introduce Heather Hanley. So it's taken some effort to get this organized, but she's finally here remotely to be able to give us a presentation. And so just a little background about Heather. She did her undergrad at the University of Edinburgh and then went on to Durham University to do her PhD. And then she came to Australia to do a postdoc at Macquarie. And then she's continued on there with, I think, a little break in between, but she did do a couple, did her postdoc, and then she got to ARC Future Fellow. And then she became senior lecturer at Macquarie. And then in 2018, she became associate professor. And one other important thing to note of what her expertise and part of her portfolio is that she's the president of WOMISA, which is the Women in Earth and Environmental Sciences Australasia Network. And so I encourage everyone to check them out if you're not already familiar with that group. A wonderful resource for many of us in the region. And so without further ado, I'll let Heather start telling us about mainland Australia's next volcanic eruption. Thank you very much.
Thanks very much, Megan. It's a pleasure to be online with you. So first of all, I'd just like to start by acknowledging the traditional custodians of the Macquarie University land, where I'm talking from today. So that's the Watamatagal clan of the Darug Nation, and I pay my respects to elders past, present and future. So in this talk today, I'd like to just really give you an overview of the different approaches that I've been taking to understand more about Australia's volcanic past and potentially future activity. So we're going to really highlight three current studies that are underway. So a lot of this work is in progress, it's not published yet. So I'll try and share what I can without giving too much away. Hoping we would have been a bit further along with some of these, but obviously the last 3 months have thrown a spanner in the progress in a number of ways. And the main question really I want to ask from this talk is, should we really be doing more to prepare for a volcanic eruption, either within Australia or from outside Australia? So I'm not sure what comes to your mind when you think of Australia, but these are the things that came to my mind before moving here from the UK in 2007. Kangaroos, koalas, beaches, ice creams, and lots of spiders. From chatting to people, I guess around on the street, mums, people that I meet, most people are unaware of Australia's rich volcanic history and how relatively young, geologically speaking, that it is. So I spent, I guess, my first 10 years in Australia working on Indonesia, in Vanuatu, on volcanoes there, and then I moved. So after having children, I probably had to move a bit closer to home for field work and things. So I started working in New Zealand on subduction plate, subduction zone volcanoes. So the same stuff I'd kind of been doing in Indonesia and Vanuatu, and then I got interested in the intraplate. So I'm going to show a slide anyway to explain the difference between, I guess, subduction zone and intraplate volcanoes in a second. But it wasn't, until maybe 2 years ago. So I guess, about this time 2 years ago, that I really started to get an interest in Australia's history, volcanic history, and volcanic heritage too. So it's a relatively new area for me, but I'm absolutely hooked and I think it's fascinating. So I'd like to share some of that with you today. So active volcanoes. So one thing that we'll go in today is about whether, how we classify things as active or not. There's no doubt Australia does have active volcanoes, but we have to move off the mainland to go and see them. So these are down the Heard and McDonald Islands down in the southern Indian Ocean. So you can see Antarctica down the bottom there. Here's Australia. And these are UNESCO World Heritage Status islands. So for their biodiversity, their, pristine nature and untouched landscapes. But these are the, if you're thinking of active, that most people probably would attribute to active volcanoes, these are the ones. So these are Australia's active volcanoes, a long way from the mainland. So last eruption on Heard Island was around a period between 2012 to 2019, and McDonald Islands. So McDonald Island recently became active again after they think about 75,000 years of dormancy. So then it started erupting again, and now the last one was witnessed by a CSIRO, boat or ship that was doing some research down that area. So they saw an eruption observed in 2016. And the problem with really knowing how active these are is obviously that it's quite hard to monitor because it's not somewhere near where anybody's going very frequently. So in terms of plate tectonics, so we often associate volcanoes with plate boundaries, whether these are divergent, so pulling apart like the mid-ocean ridges here, or whether these are convergent, so they're coming together and into these subduction zones, such as we find around the Ring of Fire. And you can see here that Australia sits in the middle of a plate, so it's in an intraplate setting. And there aren't that many red triangles. We have got one down here which signifies the Neovolcanic province, but few volcanoes highlighted here, and we're in an intraplate setting. So it's not really, I guess, any surprise that we'd not expect the public to be not really concerned about volcanoes in Australia. So in terms of the outline of the talk today, so first of all, just to highlight, I guess the classification of whether something's active or not really plays a role here. And we can see that there's a lot of confusion even within the scientific community of whether or not the mainland of Australia is volcanically active or not. After that, I'm going to then have a look at some Indigenous knowledge of past eruptions that have occurred in Australia. And these are with collaborators, Cara and Patrick. And I just started a connection with Lee Franks, who's online today. So he's working on the Gagubadan of the Kinrara eruption in northeast Queensland and oral traditions in that area. Then we're going to look at some scientific insight into activity in Australia, volcanic activity in Australia. So with some current collaborations and projects that are underway with people highlighted. And then also started up last year a study looking at the public's perception of volcanic hazard and risks with international and national collaborators. So I'm going to highlight some of the early results from that study as well. And then a kind of a what next and what should we do from here. So intraplate volcanism, it's far from a plate boundary, and we can see that Australia, this is the east coast here of Australia, and all these different coloured highlighted, I guess, blobs are volcanoes or volcanic fields that stretch over 4,000 kilometres down the east coast of the continent. The yellow ones that you see, these are what we call the central shield volcanoes, and there is thought to be a progression in age, so they get younger towards the south. So this one is thought to be related to more of a hotspot type Hawaiian style volcanism. So where you might have this enormously hot mantle or this upwelling of mantle over that then you have a moving plate, and as that plate moves, the plate, so as Australia plate moves to the north, then the volcanoes are going to get younger to the south. So that's why I guess what's been attributed to some of these seamount chains that we get, and then there's maybe at least, well, I think we're up to three potential hotspot trails across Australia down the east coast. So this is really today I'm focusing on volcanoes that have erupted in the Cenozoic, so in the last 66 million years, but more so than that, I'd really like to focus on those areas that look like they've got the youngest volcanoes and may be potentially active in the future. So these then are the red areas here. So these are our lava fields. So I'll show on there, I think on the next slide or two, what lava fields might look like in terms of where the volcanoes are and how they're spatially arranged. But one of the youngest ones in Australia, so where the most recent eruptions are down here in South Australia, so at Mount Gambier and Mount Schank. And they're thought to have erupted about 5,000 years ago, so relatively recent. So this is what one of these fields looks like. So this is the Neovolcanic province that was in that blue circle on the last slide. And you can see that every one of these dots on here is a volcanic centre. And there are over 400 known centres in this field that have been active since the last 4.5 million years to 5,000 years ago. And this actually is one of the largest volcanic fields that we have on the continents of the Earth, and it occupies over 23,000 kilometres. So we're really lucky to have this on our doorstep, so to speak. And there are a lot of, I guess, differences in the lithosphere, so in the crust and apple mantle structure beneath here, and in the presence and not of aquifers that affect the kind of volcanic landforms that you get. So each of these different coloured dots is a different style of volcanism, of eruption processes, and of landforms that get created through those. And then if we look up to northeast Queensland, there's also an area up here that we see these young volcanoes. And that's why, you know, it's often thought that it doesn't relate to this kind of hotspot trail that the other ones are related to, because we actually get the youngest volcanoes on the continent in the northeast of Queensland and in southeast Australia. And you can see from some of these images around of these two areas, we've got some really spectacular volcanic landscapes in this area. So the focus of, I guess, my interest coming from working in places that are extremely active is more so on these areas in northeast Queensland. So there's the Atherton or McBride province, and also down in Victoria in the Newer Volcanic Province in South Australia. So I'll highlight some of the studies in these areas that we're working on at the moment. So active or not. So I guess there's no wonder we can't expect the public to I guess, make an informed decision on this, because as a geoscientist, or as a number of geoscientists in the media, we're giving them, I guess, a real range of comments about whether or not there could be activity in Australia. So I just wanted to highlight here, this is 5 quotes from 5 different academics from around the country that are talking about activity in Australia that have been in the media, so in newspaper articles. And it was actually a Daily Mail article, so I read this for the first time in there, that captured these and put them together, and just to show the conflict in opinion that we have as geoscientists on the active status of Australia. So first one, there's a possibility of an eruption, but it's low risk. The next one was someone from ANU. So an eruption could hit Melbourne at any moment. In terms of Melbourne and Auckland, there's every chance another volcano could blow. You could see lava flowing down Bourke Street. And the next one from Sydney Uni said, and I've obviously not given any names because I didn't want to embarrass anybody, but the next one from Sydney Uni said, there are no active volcanoes on the Australian continent. However, if you're a time traveller and land in Australia in 5,000 years, you better watch out. Someone from Utah said, Melbourne locals should prepare for potential disaster. From what we can establish now, we're in a long phase of dormancy, and that there is the possibility of an eruption in this province. And then also from Macquarie, another colleague, actually this one was me, there is a lot more work that Australia should be doing to prepare for a future eruption. So you can see the range of perspectives that experts, scientific experts or geoscientists in Australia are providing to the public. So it's very confusing. And I think this mostly comes around from actually defining what is active. So, you know, if you're thinking, okay, well, I'm going to go get some advice, where would I get it? You know, you're probably going to end up at Geoscience Australia if you want to know about volcanoes in Australia. So I went to the website to find out what Geoscience Australia had to say, and they say that mainland Australia currently has no active volcanoes. So again, I think this just comes down to how, you know, what do we mean by active and how do we define it? And I think we're probably going to have to be a little bit clearer as a community so that we're not confusing the public on this. So what does active mean? So I think you could all agree that this top picture here of Yasur in Vanuatu erupting is active. And there are probably about 20 right now, globally, that we could say are actively erupting. But it all comes down to, I guess, the relative timescale. So because volcanoes can have, you know, hundreds of years or thousands of years of dormancy, what we consider active to be should not just match, you know, I guess, human memory or historic timescale in that sense. So I guess the Global Volcanism Programme and I guess most volcanologists that I know, we regard that if there's been an eruption in the last 10,000 years and there is potential for a future eruption in that area, then we class it as active. So it's a kind of a bit looser definition in that sense than something that we can actually see as either kicking off steam or a lava flow at present time. But it also comes down to what you define as a volcano, and this is what I think is really specific to Australia. So I've copied up this, I guess, Newer Volcanic map of distribution map of volcanic centres in the Newer Volcanic Province down here again. And what you can, if somebody asked me if Mount Gambier was active, I'd say no, it was extinct. If somebody asked me if Mount Elephant was active, I'd say no, it's extinct. So actually all of these volcanoes in this area, I would classify as extinct. I would not expect them to erupt again. But it's the whole field as a whole that I would consider to be active. So there's obviously a lot of confusion too about and I find this talking to the media, is, you know, trying to tell them that it's not that volcano that's active, but it's the actual region that could potentially see an eruption. And the chance of it being in the same place is probably quite small. So yeah, it really defines whether you're talking about an individual vent, you know, an actual edifice or complex, or wider on a field, and what time scale. But I think it's something that we should, as a community, make a bit clearer to the public overall. So Indigenous knowledge. So I guess European arrival in Australia has just been a matter of hundreds of years. But before that, we know, well, we think at least for 65,000 years before that, there's been human occupation of Australia. And some of the young volcanoes that we have definitely erupted within that time scale. So there's a really strong possibility that humans in Australia have witnessed volcanic eruptions in Australia over the time scale of activity of the more recent eruptions. So we know for a fact that Indigenous Australians have witnessed volcanic eruptions, and one piece of evidence for that is Tower Hill, which is this Maar volcano and cone complex in the Newer Volcanic Province down here. They found a human axe buried underneath the volcanic ash of the volcano. And that volcano has been dated to about 37,000 years old. So I think Erin Machin and others at Melbourne have just recently confirmed that date with some new ages that they've produced from argon dating. So we can say that, yes, there were definitely humans living in Australia around 37,000 years ago in the Victorian region, and that would have witnessed at least Tower Hill erupting. The other clues that we get are in the name places. So many of the volcanoes, or the, I guess those kind of topographic landforms, or the Maar volcanoes, for at least the scoria cones, have names that refer to them as hills of fire or places of heat. So there's a knowledge there that, I mean, at present day, you know, you go to these areas, you don't, you know, nothing's glowing, there's nothing hot. So there's obviously a memory there, or at least an interpretation or an application of other knowledge to these areas, that they recognize them as volcanoes, and that's probably from witnessing volcanic eruptions. And then we have a large number of oral traditions. So in pre-literate times, oral traditions were the way to pass on knowledge to future generations, to either protect, pass on knowledge in terms of creation, or in terms of warning of areas, or just advice for how to, a reaction with the landscape. So in terms of the oral traditions, I just wanted to highlight a couple. And there's a lot of work being done on this. I think there's been quite an interest in recent time, and I know Ben Wilkie's just got a new paper out on oral traditions in the Newer Volcanic Province that's come out in JBGR, or it's in press at the moment. And Lee Franks, who's online, is also working in the Conrara flow, which you can see up here. And then I've been working with Carol and Patrick on I guess a wider Australasia study, but very much focused on oral traditions of volcanic eruptions in Australia. So I guess one thing that bothers me is we often see a lot of things that say, oh, scientific knowledge is confirming oral traditions. And that's obviously clearly not the way that we should be thinking or talking about this. But what we should be thinking about, I feel, is that integrating Western scientific knowledge, which obviously comes from a different history of process of thinking, integrate that knowledge with Indigenous knowledge. And from that, we can really advance our understanding of volcanic activity, and whether that's pre-eruption, what was going on pre-eruption, eruption hazards, or relative timing of eruptions. And the one I guess for Australia, it becomes really important because we've had such isolation for tens of thousands of years. And because our volcanic activity is so sporadic in time and space, that, you know, we really need to learn as much as we can about how eruptions have occurred here in the past. And the best way of that is to try and get information from people that may have witnessed that in the past, or had their interpretations, and pass them on to future generations. So one of the oral traditions concerns 3 volcanic centres in the South Australian part of the Newer Volcanic Province. So Mount Muirhead, Mount Shank, and Mount Gambier. And this was the Wandik people of South Australia that had a story about a great ancestor, or a great giant or ancestor called Cratebull, and his family. And they settled at Mount Muirhead and made an oven. So this then is telling us that possibly, you know, it's related to the ground being hot. or they were aware that, you know, volcanic activity is hot. But they were woken on a night time of a noisy bird they called the bulin. So from there, then they fled to Mount Schank, where they thought they would be safe. But then one night again, there was the voice of this bulin, or this bird, occurred again. Now that could be some sort of precursory warning to volcanic eruptions coming. It could be the steam coming out, or it could be related to sort of a pre-eruption warning of an event. So from Mount Schank, when I guess an eruption occurred again, they moved to Mount Gambier and camped there for a long time. But the water came up from the bottom and put out their fire. So they made 4 more ovens, which relates to the 4 different, I guess, landforms we've got, these Mars today, but each time the water came up. So this was recorded by a missionary, Mrs. Smith, in 1880. So this was from interactions with Indigenous Australians when she moved to Australia. So I think there's a number of things. One of the most interesting things for me from this story is that Mount Schank and Mount Gambier are both thought to have erupted around, 4,500–5,000 years ago. And the paleomagnetism suggests that they were about 300 years apart from each other, but can't tell you which one came first. So I think, gathering from this story, you can make an inference that from at least the oral tradition, it indicates that Mount Schank erupted prior to Mount Gambier. So I think if you can take the information away from these, we can start to, I guess, improve our understanding of the evolution of volcanic events in the country. And then, so that's down in Southeast Australia, but also from the younger volcanic eruptions up in Northeast Queensland. We also have a number of oral traditions recorded up there again. So the one I just wanted to highlight from here is one from Lake Eacham or Yidgim, and that's in the Atherton Tablelands. You can see it there. It's one of these explosive Mar volcanoes. So we don't have the best date I can find on this is actually the oldest sediment in the actual lake, which has come out about 9,000 years. So that's regarded as a minimum age, but I guess from papers I've read, it suggests that they happened in the Holocene, so like in the last 11,000 years or so. So pretty young by geological standard. And what the story, the oral tradition tells us is that there was open scrub in this area, not the forest or the rainforest that we see today. And that there were a group of people sitting around in huts in this area. And there was a group of old people that were looking after some recently initiated men. So one old man got up to go and look for food and told the initiated men to stay there. And now at this point, there's a few different, I guess, versions of a very similar story of this. So one of these stories, where the old man then said it got unexpectedly dark, and he knew from that the initiated men were in trouble. So he started to try and get back to the camp. When he got back to the camp, there was a cloud up in the sky, and it was up high, and it was getting yellower, and the wind was blowing strongly, and a cold wind was rising up. And then he saw water rushing and engulfing everything. So, and then it says that all the animals came running at that point, and they were trying to escape the water and in part carried by the wind. And the old man cut and hit the ground to try and make it stop around the camp and threw fire, but the water came up anyway, and the people perished. So from this, I think there's a number of things that you can, from this eruption, there are a number of things from this story, there are a number of things that link quite clearly to volcanic eruptions and the types of things that you'd expect to see. So I think there's a lot we can get from that. And one interesting thing is that pollen analysis by Kershaw in 1970. So this myth or this oral tradition story was recorded prior to this study in the 1970s. And there they did a pollen analysis, and they showed that the rainforest biota was less than 7,600 years old. So the reference to the open scrub in the oral tradition, obviously corresponds or can complement the pollen analysis study that they got to confirm about the biota at the time. So I think there's a lot of things we can gain from oral traditions. There's a lot more work to be done. It's obviously got there's obviously challenges and limitations in terms of we can have situations where stories are adopted from other areas. So it's trying to understand, there's stories of 2 volcanoes fighting in one area, and very nearby there's another story of two volcanoes fighting. So, and two of those volcanoes, you know, are from eruptions that are thought to have occurred from scientific dating more than 200,000 years ago. So there probably is some sort of adoption, but it just shows that Aboriginal Australians were definitely in the landscape when eruptions occurred. And I think that's really important from a different viewpoint, and I guess a connectivity to that volcanic activity that European settlers, and when they arrived, have just not had, because it's not happened in the time frame that I guess literate history has been occurring. So we're going to switch I guess topics a little bit now and move on to the second one. So for this one, so we know that volcanoes have erupted in human occupation of Australia. Is it going to happen again? So the field in the New Volcanic Province has been active for 4.5 million. We know that some of these fields, so the one on the Victoria, there's a volcanic field on the Victoria, New South Wales border. We know that that one was active for 20 million years. So it's not particularly a long period of time, geologically speaking. So we could expect future eruptions to occur. And we also have geophysical evidence, and a lot of the ANU group are working on those aspects that suggest there might be small degrees of little bits of melt down in the area in the New Volcanic Province that might be related to either past intrusions or future intrusions of melt. So I think we could definitely say, you know, I would say we definitely expect one to happen. So then the question is, what can we learn about what it might look like and how much warning time we might have? And in terms of warning time, one way we can look at this with volcanology and mineralogy is from these dark green chunks you can see in the rock here. And these are fragments of the Earth's upper mantle that have been brought to the surface in the black material around it, which is the basaltic material. So from these heavy, dense mantle xenoliths, we can get an idea that for the typical size you see, you know, these are dense fragments of the Earth's mantle. You're going to have to move pretty fast to actually be able to carry these without them settling out from the magma that's moving towards the surface. So from looking at the size of the xenolith, I guess assuming a round shape, looking at the conduit and the flow dynamics, calculations suggest that for the typical size xenoliths that we find in these areas in Northeast Queensland and South Australia, you're going to be moving from the upper mantle to the surface, or you have to move from the upper mantle to the surface in just a matter of a few days. So this would then actually correspond to your maximum warning time, because if you're moving from the upper mantle, you're probably not going to be starting to get the earthquakes at that point. You may not start to see earthquakes associated with any activity until it gets closer towards the surface. So I think this is a really key point, the fact that these volcanoes are bringing up, so it's not all the volcanoes, but many of the volcanoes bring up these mantle xenoliths, and quite large ones suggest that we are going to be moving fast from the source to the surface. So we can look also in terms of, for the mineral, we can look at their shapes and we can look at their chemical zoning pattern. So here I've just got a selection of backscattered electron images from the Scanning Electron Microscope, or SEM. So some from the Atherton Province and the New Volcanic Province that I'm working on, and that Rosa and Tom England are working on as well at the moment. So most of these images have come off in the last, well, some came off in the last few weeks, some came off in the last few months, so pretty new parts of the study we're doing. But what you can see automatically is you can see the colour, the grayscale contrasts. So those grayscale contrasts that you can see, so whether you've got the kind of rings here or whether you've got this lighter edge to this, darker interior, these correspond to chemical contrasts in the crystal. So in the same way that when a tree is growing, it records its environment in terms of precipitation, I guess, temperature, and you can use dendrochronology to like have a look at the past environment when the tree was growing. You can do the same with crystals in a melt. So crystals in a magma, as they're growing, they take on the conditions of their surroundings. So we can use these, I guess, zoning patterns, chemical zoning patterns in crystals that we see to tell us something about the plumbing systems and their ascent pathways to the surface. So this one on the left is an olivine xenocryst. So xenocryst just means a foreign fragment. So it's something that didn't grow itself from the magma, but it's been picked up. So in this case, this is actually a mantle, So one of those xenoliths that you saw on the past, a bit of fragment of the Earth's mantle, this is then a crystal that's been come out of that rock, that green rock that you saw. I just wanted to help, so also about the shapes of crystals. So if you see here, we've got quite different shapes to the last one, and we call these kind of skeletal, so skeletal olivines, and also dendritic. We've got some dendritic features in there, very small microlites in this volcanic glass. So we can also use these types of textures because these are related to how much you cool a magma and how long it takes to cool that magma. So basically when you find skeletal and dendritic textures, it tends to indicate that you've had larger amounts of cooling over faster timescales. So what we can do by combining information, the chemical information that we get from looking at these zoning patterns in some of these crystals, and combine that with the textures and the shapes that we get from the minerals within there, then we can look at everything from, imagine it's a xenocryst, we can pick that up in the mantle, and then we can look at what's going on in the magma or the volcanic glass that tells us about the shallow part of the surface. So what we can do by looking at the minerals and the mineral chemistry and the shapes and the morphology, we can then kind of map out the plumbing system from source to surface and see, you know, what's going on in terms of conditions of temperature and pressure. I just wanted to share this one as well. So I think I've got some spectacular images from some of these Australian volcanic rocks. This is another one from the Atherton volcanic province, and you can see these dendritic clinopyroxene, super tiny microlites in there, in this really, I guess, clear and fresh glass. And if you start looking at them for long enough, you start to even see little people in there at times. So what do we do to get the actual time scale out of how fast the magma is moving from source to surface? So we use something called, I guess, diffusion chronology. So imagine you have a crystal. So we'll start off the bottom down here. We have this crystal. It's one of the early formed crystals when it started to grow. And for example, it had a high magnesium content up here. Then it may have mixed with a composition that was different. So it may have come into either a reservoir or a chamber, or it might be this could have been a mantle xenocryst that got plucked out and picked up by the melt. So this could then have ended up in the magma. So you can have xenocryst magma interaction or some sort of magma mixing. But where you get those kind of chemical temperature and pressure type contrasts, then you're going to grow a rim of different composition, which is what we've got down here. And you can see down here. So over time, then we have this big boundary here. So we've gone from, I guess, a homogeneous composition to a rim of different composition. And then over time, what happens is it tries to diffuse to find an equilibrium. So what we can do is use this gap with some, I guess, fancy modeling. You can use the gap in here and some assumptions. You can work out the gap and the time frame to go from where this profile would have, when it happened, so the mixing event, or when the xenocryst was picked up, or that surface was exposed to the melt, and to eruption time. So this is what it would look like if you started off, if you imagine this is going from the rim over here of the crystal into the interior towards the core over here of the crystal. And at some point we had some sort of mixing event or some interaction between a xenocryst and a melt. And that was our initial part. And then here it just shows you as time progresses, this curve gets shallower and shallower. So you can fit the model to that to work out the time. So Rosa Didona, a postdoc here, has started to work on this for, I guess, 2 centres at least in the Neovolcanic province. So Mount Noorat, and you can see all these bright coloured grains in here. These are all parts of the mantle. So either mantle xenoliths if it's multiple grains, or the xenocryst if it's individual grains. So what she's starting to do is, I guess, do profiles, chemical profiles on the electron microprobe from going from the rim of these xenoliths to the interior. And then we can look for these profiles that are going to indicate our diffusion timescales. So this is where we're up to at the moment. So we've just got starting to get the data off the microprobe. So the next step then is to try to start modeling the diffusion timescales to see how long this has been sat within this kind of host basaltic rock, which would have been the magma as it was ascending to the surface. So the last part of this talk, I just want to focus a bit on what the public's opinion is. So if we're going to respond to a volcanic hazard, we really need to know what the public, I guess, perception is of and awareness is of volcanic hazards and risk. And Australia, I think we can all, I guess, agree that Australia can be at risk from volcanic activity from overseas. You know, we've seen, I guess, cases of eruptions in Chile that have affected Melbourne or Sydney airspace. We're surrounded by volcanically active areas, so Indonesia, Papua New Guinea, New Zealand, Vanuatu, and some of these countries are capable of supervolcanic eruptions. So it's possible that we could be at risk from an eruption outside Australia. But I also wanted to know what people think about eruption risk from inside Australia, so on the mainland. So I started to team up with some social scientists, and in, I guess, November last year, got through all the ethics approval process and launched a quantitative anonymous survey with about 38 questions in there. We've had about 120 responses to date, and I haven't really pushed the survey in the last 6 months. That was pretty much most of last year. We managed to get, well, actually it was in a month or two, right? We managed to get that many responses, but I haven't really pushed it in the last few months because of the White Island eruption. There was kind of a sensitivity. You know, I know people in schools here where families were affected by that, and they were quite sensitive to it. And also then we were under the bushfires, and then now coronavirus. So, you know, trying to get people's perspective on volcanic hazard and risk. So we've got some responses which will be interesting to see prior to bushfires, after bushfires, and before White Island and after White Island, so we can have a look at that information, I guess, on a more detailed level to see if it's affected people's opinions. But one comment here in the kind of general comment box at the end was, if there was a volcanic eruption, I would have no clue what to do, where to go, or who to ask. And I think that's one thing that we should try to address anyway within the community, that people do know where they should go to, even if it's just an emergency services website. So I've just grabbed these diagrams off of Qualtrics. So some of the questions we asked 38 questions. We captured a lot of demographic info, so age, gender, we've got you know, what level of earth science qualification they have, or we've got the general interest in earth science. And then we started to ask them just generally how concerned they are about risks from following hazards. So most of this data was collected before January this year. There's been probably five since then. And you can see that I've just highlighted here. So this was a 5-point Likert scale. So they could rank things if they were concerned or not on a scale of 5. But I've just highlighted the 2 N members here. So extremely concerned in red and not at all concerned in blue. And you can see that in terms of volcanic activity, which I've highlighted in that blue rectangle, over, what's that, close to 65% of people were not at all concerned. So the least concerned about volcanic activity. And you can see for the red ones, we've got most people concerned about climate change, drought, bushfires, housing affordability, so the things that you could imagine would normally be of concern to people in Australia. So Australia's at risk from, and this was asking people whether they agreed with this or not. So in terms of, I guess, what people thought they're most at risk from is, again, the bushfires, flooding, is basically most of the other hazards apart from tsunamis, earthquakes, landslides, and volcanoes. So you can see that, again, people don't necessarily think that there's much risk from within Australia, but maybe a slightly more people thought there might be a risk from, they somewhat agree with that there might be a risk from volcanic activity outside of Australia. And so we asked them the question, when was the last eruption in mainland Australia, to see what they thought about that. And I guess from the data we have on what background people have, their highest degree, their level of interest, whether they've done year 12 earth science, we can see that, obviously, because we've distributed this survey at the moment through our networks, we got a lot of scientists like filling in the survey. So there's 2 boxes here. One is that I'm not sure box. So a lot of people really not sure when the last eruption was. And then we have got people that recognised, I guess, the correct time frame for the last eruption. But I haven't really gone into the data to see what background knowledge yet people had to guide that opinion. So in terms of preparedness, how well did people feel were prepared for dealing with volcanic eruptions? Well, nobody strongly agreed that we were prepared for dealing with them. And then there were quite a lot of people that just didn't really know whether we were prepared or not, and a lot of people that disagreed that we were prepared. Do they know whether to follow the procedures if there was an emergency related to eruptions? Well, most people said they didn't, and most people weren't aware of any preparedness, emergency management plans or warning systems for volcanic hazards in Australia. So this is the survey flyer. If you do want to pass it on to your family and friends, we're trying to get less scientists completing it. Yeah, then please pass on this slide when it goes to when the recorded version's posted, because it'd be great to get more people to complete the survey. And one thing I just want to say here is, so in terms of level of preparedness, if there was going to be an eruption, or if you wanted to find out about volcanoes and you were living in Victoria, where the new volcanic province has the majority of volcanic centres, you'd probably likely end up here, which is the Victorian Emergency website. And you can see they offer information on a range of hazards here. So we've got fires, floods, storms, earthquakes, tsunamis, thunderstorm asthma, extreme heat. But what they don't have is volcanic activity, whether that's from outside or inside, like what to do or how to prepare. You know, it could be about protecting from volcanic ash, if it's something from external. But what they do, one thing that really struck me was if you go to tsunami and prepare for a tsunami, it mentions that tsunamis can be generated by meteorite impacts. And I just thought something's not quite right here. So they mention on the website for Victoria, which I believe has an active volcanic field, that tsunamis might be generated by meteorite impacts, but don't consider, you know, the potential of a volcanic eruption in a volcanically active area. So what would be the impacts? So this was I guess an interesting concept that was put together in Ray Cass's 2017 kind of review paper of the new volcanic province. And Joshua Van Attelu's PhD work identified or determined that the Mount Gambier eruption, so the last one in 5,000 years ago, had a volcanic explosivity index of 4. So this is on the scale of 0 to 8, where 8 would be a supervolcanic eruption and 0 would be something like in Hawaii that you could walk away from, like a gentle lava flow. So 4 is pretty significant. And the Icelandic eruption, Eyjafjallajökull in Europe that ground, I guess, most of the European airspace, was also a VEI 4. So what Ray and others did was to superimpose the ash cloud from the Eyjafjallajökull eruption onto Mount Gambier with prevailing, you know, normal prevailing wind conditions to see what might happen. So you can see from that it's kind of an extensive ash cloud. There would be ash on the ground or ash in the air that might travel even all the way to New Zealand. What else might we expect if we see an eruption? So the Undara lava caves in the McBride province are about 190,000 years old, but they're 160 kilometers long, these lava flow. That makes it one of the longest Cenozoic lava flows on the planet. Second, I think it's third to two others, one in Argentina and one in the USA. So significant lava flows in the McBride province in the past. And it would probably end up looking something similar to what we saw in Hawaii in 2018. So what would the warning signs be? So close to the end now. So what would the warning signs be if we were going to see signs of an eruption? So I think we can use Hawaii as a good analogy for this too. So you could see possibly some small earthquakes, maybe minor uplift or subsidence, changes in the ground temperature or gas and steam rising out. But if you think about moving back to the xenolith study, so we're seeing timescales there from at least modelling the size and density of those xenoliths and the settling out of them, that you're going to have about 2 or 3 days. You could potentially have 2 or 3 days only notice. So I think it's really important to do a bit more work in terms of the petrography and direct analysis on certain particular centres across the fields to see what those ranging timescales are for how long it takes to get from a source to surface or from a stalling point, maybe at the MOHO, to the surface. So if you want to find out more or learn more about intraplate volcanism in Australia, we're organising an online symposium. Everybody's welcome. that's going to be on Tuesday, the 22nd of September. It's going to be split into 3 themes. We're going to try and use this opportunity to bring everyone together to look at a range of knowledge and approaches on interplate volcanism and its impact on the environment and on humans. So we're going to have a theme that's on deep beginnings, more focused on the source. The second one will be how we get from the source to the surface. And the third one will be, once we're at the surface, kind of the impacts on there, and also include aspects about education and outreach. So if you want any more information about that, please ask me or send me an email. And then the other little pitch, I guess, and Megan already gave one for me, is just about WMESA. So yeah, if you want to find out more about the Women in Earth and Environmental Sciences Australasia Network, then I'm really happy to chat to you more about that, about how you might be able to get involved. And we are looking for a treasurer at the moment, so if anybody's interested in a treasury role, then please get in touch. And we just had, this week, we had confirmation that a paper that we've prepared for, it's the Advances in Geoscience Journal for EGU Journal, and it's our paper entitled In Australasia, Gender is Still on the Agenda in Geosciences. So that's coming out soon, so I'll be happy to share that with everyone too. And just to leave you, so I guess in summary, here's a nice, I guess, video flyover of Mount Schank, just to show you what incredible landscapes we have in Australia, volcanic landscapes. Yeah, and I think that we could all be doing a lot more to understand, I guess, volcanic and magmatic processes in Australia, and then, you know, how that links to any future potential eruption, and combine it with a range of approaches, which I've tried to highlight in this talk today. Thank you.
Thank you very much, Heather. I've released the mute unmute button, so people are probably furiously clapping. I can see a few symbols appearing of claps. Let me just remind people that to join the question session, please use the raise your hand button. There was an interesting discussion in the chat that went on halfway through there, and the last person to contribute was Rodri. So I don't know, Rodri, if you wanted to summarize the discussion as in the form of a question or comment, and then we'll pass on to people who have who raised their hands.
Yeah, I can try my best. So I think Heather, first of all, thank you for a wonderful talk. It's nice to see you again. I think the discussion in the chat that Louis is referring to was there was a question on whether or not there was an age progression to the west in the newer volcanics, because it seems, I think, some of those South Australian volcanoes are a lot younger than those to the east. But I think from my understanding, Ian McDougall, Ray Cass and others have said that there's probably not an age progression there. Do you understand that to be the same, or have I got that wrong?
Yeah, no, I understand the same. So yeah, I mean, it looks apparent that there might be the younger volcanism, or the most recent volcanism is in the west. It might be the case, but one of the problems I think we've got is that we just don't have enough dates of enough of the centers to actually be able to determine that correctly. I think last time I was talking to Ray, he said there's only about 40, of the 400 that we think we've got a really good age constraint on. So I guess we can do spatial analysis and you can do geomorphology or something, but until you've got a lot more dates. And the one thing for the Kinrara up in northeast Queensland, I think when I was a potassium argon date, I don't remember the exact date, but I'm pretty sure it was something like 30,000 years for potassium argon. Then Cohen and others did argon dating and came up with an age of 7,000 plus or minus 2. So most of the dates in the neovolcanic province, I think, are coming from potassium argon dating too. So there's another question of, if we start redating with the argon, are we going to get slightly different ages? But I think my understanding too was that they cannot see at the moment that there's an age progression with the information available.
Thank you.
Okay, thank you. There's a question from Michael, who typed it into the chat box, which is now scrolling off of where I can read it from. Hang on. Which said, back when the area was volcanically more active, how often were the eruptions? Were people living at the time likely to see an eruption during their lifetimes, as is the case now in Hawaii or Indonesia, or was it something that could happen once every several generations and then people would learn about it from the oral history?
Yeah, so I think that's another thing where it comes back to having a better age constraint. So at least for Mount Gambier and Schank, the paleomagnetic, as far as I understand, suggests about 300 years apart. So there is, once you start, trying to, I guess, get all the age dates, I mean, you see the variation you get in the age dates, so it is hard to know for sure. But that one seems to be, for me, I guess, a point that even 300 years, it's still quite a few generations to pass on that knowledge down. Obviously it's doable. You think about nursery rhymes or oral traditions that we have even in such a literate world today. You still make those things happen. But in terms of the sporadic, the average frequency, if you think you've got 400 vents and it's been active for about 4.5 million years, is about once every 12,000 years. But there was a study where they think it is in clusters. So you get periods of activity and then probably quite long lulls and then periods of activity. But even those periods of activity might still be, in the order of thousands of years between, hundreds or thousands of years between eruption. So I think it's something we still need to work on a lot. And that's one thing that we're probably going to bring up in the symposium, is the need for better age constraints on a lot of the volcanic eruptions. But it also comes into play that, if you're saying to the public, well, this volcanic field, it erupts once every 12,000 years. And they go, well, how long was the last one? And they say, okay, 5,000 years. So, and then everybody thinks, okay, well, I've got another 7,000 years till the next one. But it doesn't happen like that. And I think one thing in communicating those kind of frequencies to the public is making sure that they understand that it's just an average, and we do get clusters and we can have active periods, and it can go, dormant for thousands of years in between.
Thank you. Zachary, looks like you had your hand up next if you want to go.
Yeah, thanks for the talk, Heather. It was really interesting. I was just wondering, with your diffusion profiles across the olivine, did you notice any significant changes in the ratio of aluminium and silicon at all?
So I haven't looked at so Rosa's just got that off the probe. I'm working on Mount Schank. Rosa's working on Mount Laura and Mount Norat, and then I'm also working on one in the Atherton field. So I haven't got as far as the probe yet to get the data off, but Rosa's got the multi-elements. I don't think the aluminium was from memory, it wasn't a great trend. I mean, the calcium, iron, magnesium, phosphorus peaked at the rim, as you'd probably expect. So there were some changes, but I don't remember for the aluminium and silicon what it was doing. Sorry. I can have a look. I'll get Rosa to let you know.
Cool, thanks.
Thank you. We've got both. Anthony, did you want to ask your question in real life, or shall I read it from the chat? And after that, Richard. Okay, I'm going to read it. Let's scroll off the screen again. Can you comment on the level of volatiles in the Australian intraplate magmas and what they imply for volcanic hazard, Anthony Burnham?
So I think in terms of the hazard, so I guess there's two things there. One is in terms of the source. So I don't know what the exact percentage they think from maybe melt inclusion work or from other constraints on the volatile content of the source. And it's not really my scope of study in terms of looking at that aspect. So I'd refer you to Steve Foley and Isra at Macquarie Uni to probably get a better insight on the volatiles in the source. Now we do see evidence of the volatiles through the types of minerals that we find in terms of the hydrous minerals. So there is evidence that it's there and it's a metasomatized type source, but I don't know the exact, it'd be something that I don't even know if the people have done much in the way of melt inclusions to have a look at potential volatile contents. But in terms of the eruption controls with volatiles, I guess, or water at shallow levels, one thing that really controls eruption is that you could see on that neovolcanic province map that a lot of the areas where you've got the limestone aquifers and the groundwater or surface water in the south part of the field, and also over in Mount Gambier, is where you're getting the more explosive water magma interactions, and that's where you're creating those larger scale eruptions, explosive eruptions, as opposed to effusive lava flows that you find in the areas where you don't have the aquifers. So volatiles or water in the shallow system, actually, in the ascent dynamics are very important, and that might be a bigger control than volatiles in the source, which may have degassed by the time you get to the surface. But you do get liquid carbon dioxide wells that they mine around the Mount Gambier province that have come back with with an isotopic signature of the mantle as opposed to the crust. So there's clearly a lot of, I guess, decarbonation coming from somewhere, but I'm not really sure in terms of what's going on in the source for that.
Thank you. So we've got Richard wanted to ask a question, and there's another written one from Lee. So we'll go with Richard first, if you can unmute, and then the last one will probably be Lee, and we'll pass on to the private chat after that. Okay.
Hello, Heather. Thanks very much. I will out myself as the ANU person who said going down Burke Street, and it was actually an interesting interaction with the press. Be careful what you say. But my response there was because they were asking me with respect to volcanic hazards for Australian cities, and whether, I think I recall the person actually knew about the new volcanic province. But when they came to Melbourne, could it happen in Melbourne? And I knew what Ray Cass had said. And in fact, when you walk around Melbourne, you can see it's built on stuff,
Yeah.
lava fields. And my comment to him was, I hope there really is one in Melbourne. I'd sell tickets for the public to go look at it. A kind of, you know, the volcano at Los Angeles style. But it was pretty much a flippant comment, but it had a sort of basis, I think, in reality, that there is a hazard all over Victoria and into South Australia.
Yeah, and I agree. I agree completely. It could happen. I mean, just because there's a city there, it's not going to just stop being an eruption if it wants to erupt there, right? So, I mean, I guess I would love to see one, but somewhere where obviously there's not going to be much damage to people, infrastructure, lives. But it would be amazing to see a lava flow.
I think
in Australia.
like Auckland, but I did have a question of you. Your survey, I could imagine if I lived in Alice Springs, my concern about tsunami would be minimal.
Yeah. Well, we've got the geographic. So I've got postcode. I've definitely got postcode, and I can't remember if we asked for suburb. I think we just went with postcode because of the typing issues. So it was going to be easier for them to just put in a number. So we will, once we get enough. So I'm aiming for about 400, I think, completed surveys in order to have in theory, a statistical representation of the Australian public. And I'm going to try and target to get regional. I need more regional. I've got obviously a lot of cities at the moment. I can see that from the postcodes. I have a lot of Sydney and I have a lot of Canberra. Just because Marina Costello very nicely distributed it to her family and friends from GA. So we will be able to do kind of, once we've got more, I guess, information back or more surveys completed, be able to do those kind of analysis then of, you know, what age, what gender, what background in terms of knowledge, what level of qualification, where they live, when they filled it in, what time what time in terms of the world's going on, so they filled in their opinion. So yeah, hopefully we'll be able to determine, you know, somebody living in the middle of Australia obviously is not going to be very concerned about a tsunami.
Yeah, okay, very good. Thanks a lot.
Thank you.
Yeah, so we're getting towards the end. There was, Lee had a hand up, and then if not, I'm going to pass on to Voon to probably to take over and do the early career student meet and greet thing. Yeah. So let's just check.
Yeah, just got a quick question for Heather.
Mm-hmm.
Thanks, Heather. That was an amazing talk. And my question is, what would you say was more likely as the next eruption mode? Would it be a Mar volcano like Mount Gambier, or an effusive volcanic eruption? What do you think it might be?
I think it's just going to be too hard to tell. I think where that geophysical anomaly is, you know, where they suggest there's some degree of partial melt, either intrusions into the lower crust or somewhere. If it erupted there, then it might be more likely to be an effusive or, you know, scoria strombolian style eruption. But judging on, I guess the last ones at Mount Gambier and Mount Shanken, they had an aspect of phreatomagmatic, you know, Mar aquifer interaction. I think, and we don't really have a spatial constraint on any pattern in time. It's just going to be too hard to tell.
Thank you. Yep.
Thanks.
All right. Thanks very much. I think let me thank you again on behalf of the school in general, and for those of you who are sort of interested in talking further to Heather now, there's an early career and student kind of meet the speaker Zoom session, which will be carrying on this link, and the rest of us are kindly invited to leave the meeting at this point. So thank you very much. I will stop the recording as well after one last thank you, and hand over to Voon to convene the next little informal session.
Thank you.
Thank you.